Petrovicheva, and today I'm going to be speaking with Ara Ghazaryan, Scylla Tech co-founder and lead data scientist. Scylla Tech focuses on real-time threat detection systems. Ara, welcome to the podcast. I'm really excited to have you here. And my first question to you, would you please describe what Scylla does, what your company is about?
All right, thanks for having me here. I'm Ara, Scylla's technical co-founder and lead data scientist. A few words about Scylla. In short, Scylla is a world-leading real-time physical threat detection solution. Our mission is to empower the private security industry with next-generation AI solutions. And with every new product in mind, we strive to make safety more accessible to those who could not afford it otherwise. We offer a wide variety of powerful AI physical security solutions, ranging from object detection, perimeter intrusion detection, thermal screening, anomaly detection, behavior recognition, person search, and false alarm filtering, to name a few. We started off as a startup back then, and now a few years passed, and we are proud to deliver our solutions to such companies as Daimler, Major League Baseball, Chicago Cubs, Oman International Airport, Legrand Mexico facilities, USC Vertigo Hills, among others. A demo of one of the solutions, specifically weapon detection, was shown a bit earlier.
Got it. Thank you. So could you please tell us a bit about how you got into this industry? What is your story?
Well, personally, mine is a little bit like cumbersome. I started in academia. My background is optical physics, and I was doing research in biomedical related optics and imaging. And then I started to use the tools. Back then, some decade ago, I used to develop the tools that nowadays are available by a single line of the code. And back then we had to develop all this matrix analysis and everything from scratch and do all the mathematics behind. And yeah, back then this image analysis and conversions and all of that, they were pretty exciting. And then at some point I met co-founders of Scylla, Albert and Armen and Ashot, and then I merged with them, brought some insight probably, and then that was the very first ideas of that Scylla was pursuing. And yeah, I jumped from my research academic life into this very exciting field, and I found I was perfect, I guess. I think so. It was a perfect puzzle piece that complemented my co-founder colleagues in this respect. And then the company, the startup grew. Initially, we were chosen as one of the startups in Startup Bootcamp in Amsterdam. Spent boosting several months there. And after that, we have these new first very important customers, and the growth was there.
Cool. So, to you, what is the main difference? So when you research algorithms in academia, right, and when you create products in a startup, what is the main difference in these types of work?
Well, I must confess, there is a difference, of course, and everyone knows that. I mean, if you're developing a product that is supposed to be later on in production, in sales, that has a very strict, let's say, goals. The more, of course, depending on the use case, it may be a customer-oriented and goal-oriented, etc. In academia, the goals are slightly different. It's more generic. It's more about all the community, and you do the research. You don't. The most important difference, one of the most important differences, is that when I'm doing stuff here in this company, I see the end product.
Yeah.
And that is very exciting. That's absolutely exciting when you see it in action. And when you see that it is potentially safeguarding at least, and then it saves some troubles for that probably would happen. And also nowadays with thermal screening and COVID-related solution that we have, you see that works on a day-to-day basis. There's a person without a mask, the system gets alerting. There's an intruder, unwanted person in the premises, you get the owner gets an alert, and we get the confirmation that the system worked and performed. And that's something that typically in academia you don't have. I mean, you just type in an article and send it out, and you don't even know whether it will be okay. Well, people cite you, and you know that some part of it was used in later researches, but the end point is not obvious unless you jump from the academia and create your own company and develop your own product or like whatever it is. So the clear difference end point here, first, it's very distinct. And it's very inspiring too. Other than like commercial part and everything, you really work on making the world safer place.
Well, that's a big mission, I would say. I would guess that there are also differences in the timelines. I would guess that in product development you do have some deadlines, which you maybe not necessarily have in academia. Obviously, in academia there are deadlines for paper submissions, but I would guess that timelines are way shorter in the product development. Am I right?
Yeah, for sure, definitely. You don't have the luxury of taking your time and then checking, over checking, and everything. But at the same time, of course, the product should be working. I mean, it's not just like cutting shortcuts and everything. They're not always justified. You cannot always afford them. And yes, the pace is much aggressive here. And to be honest, one of the personal reasons I jumped into this type of environment was also that, because I craved for this faster pace, for some let's say aggression in the development. Because in the academia you are too relaxed and you don't see things changing, and sometimes it's like really dragging. And then here, nothing like that. Fast.
And one point that I'm personally really interested in, I would guess that the reliability of this product is completely different in academia and in product development. I'm not necessarily right here, so we can discuss it, right? So when you create something in academia, you aim for your work to be published, to be continued on, but in threat detection in product, you have a completely different level of responsibility when you publish something. So you will probably need to test it way more thoroughly.
Yeah, definitely. I mean, if you're just generally, providing something, well, we are talking about computer vision, we're talking about AI, and we all know that there's some, at least big portion of statistics under. So statistics means that there's a portion of truth versus false, right? And you want to, of course, to bring this threshold to the highest, but it's always 99.99 something. The question that you raise is very important, because this 0.01 is something you are responsible and liable for in that terms. There are two things that you have to keep in mind. First thing, for sure and definitely, the end client should be aware of that. There's not a magic solution that works in 100%. This should be clarified and clearly provided, this information. That's why we have very thorough white papers with each and every product. And these white papers contain all these sorts of information. They do contain these numbers, 99s, 97.6s, and everything. So end client is aware that it's an augmentation. It doesn't substitute like completely. In some cases, yes, I mean, especially in cases where a human being cannot afford being there for, there are many solutions that I can talk about, like in drones and everything.
Yeah.
In some cases, it is like you are increasing the number of eyes of the helicopter pilot, that you put the cameras, the helicopter, and does the job that otherwise one human being wouldn't be able. But at the same time, yes, it's still 99.99 something. Our task is to bring these nines as much as possible. In many cases, I can give some numbers which are like astonishingly high and everything. So they are like two misses per week for 30 cameras or something like that. So just again, quite high numbers of accuracy, but still, it's not 100%. And if that is liability or legally and everything is covered, then we're good to go.
Got it. Yeah, this makes a lot of sense, especially given that the industry you're working with is very specific, right? You have a very big mission, but also a lot of responsibilities, I guess, here. So I wanted to talk a bit more about threat detection. Again, this is a very specific industry you're working on. What is different in artificial intelligence algorithm for threat detection compared to like general artificial intelligence applications now?
Well, again, to clarify, of course, we all understand that artificial intelligence itself as a topic and as an idea is slightly different from whatever, like for example, computer vision tasks are doing.
Yeah.
I would just add slightly what we are usually claiming, and that's in the process of our the training and implementation and everything. Our models, there's this, I will go a little bit, not too much, but take it. So when you start teach the models, I would say there's this, at least for our experience, there's a sigma type of a jump when the model is jumping to the level when it aids the training process itself. So how it works. Of course, we're talking about data sets. We're talking about the more the merrier, etc. Right? But then what we have reached so far is that our models, first of all, they are so accurate that they aid the collection of the data. So there's this back loop, and the sources that we create and we make. Previously, we used a lot of manpower. Nowadays, the system itself is at some level is self-learning. So yes, we can claim that we have much more from artificial intelligence than typically is claimed, because it's a hype word and everyone is using everything. So it's not a clean machine learning in this way. The data set is being created. So we taught the child to the level that now the child can look at the world and say, okay, I see another weapon. Here is another weapon. Let's add up to my data set, and on the next iteration become smarter. So there's a clear difference in that respect. And of course, use cases define a lot of directions. Like, it's not just boosting the numbers. You have to know what is at the end of the day is important for the client. There might be some cases where this thing is not as important than that thing. Like, detecting smaller objects can be much more important than detecting in the darkness. As an example, is one of them. So, of course, the use case tells, for example, for the implementation on the drone, smaller objects are much more important than anything else, because they overview from the high and everything is small there, etc., etc. So different use cases define the direction in which the models will be trained. It can be super cool model with highest accuracies, but then for the specific use case, this direction would be much more interesting and desirable.
Got it. I would also guess that data is really hard to come by in threat detection. Am I right?
Exactly. Yeah, you are right. And especially with nowadays, with all the privacy issues and concerns and everything, you might think that, okay, well, there are some publicly available data. Let's get them and then use them. But at the end of the day, that's well, at least not allowed for commercial use and everything. And we are very careful in that respect. That's why we ended up creating our own data sets. A lot of data sets are like literally in the field created by us in different locations. Also, we use synthetic data, synthesize them and make them out of, like, we have our own teams that do create the data. And yeah, we started with the available and commercially available data sets, and then we added up to that from our own.
Cool.
So yeah.
I would also guess that one of the problems with the public data, except for the licensing issues, in some cases at least, it's captured not in your real environment with real threats and weapons, but in some artificial environments with some actors that are a bit overplaying their role, right? So it's a bit too much and not similar to what happens in real life.
Yeah, for sure, and that is a big concern initially when we start, especially when we're talking about, let's say, action detection models, and we do have two branchings. One of them will be like object detection and tracking, the main branchings, and the second one will be mainly concerned detecting the actions themselves, like the development and the action detection models are very specific in that respect. It's very hard, and unless we are given by the client, usually that's how it works. We have, for example, we have the shoplifting solution. So it detects the shoplifting acts. The data set is provided by the client himself, and it's a huge data set, long-term recordings and everything, of course, with all the privacies and everything in mind. But then, that's how it works. It is trained on this specific data. You cannot create the shoplifting because, well, none of us is an expert in this field, luckily and hopefully. So yeah, and the same goes with the fight. You should see. I mean, sometimes we do these live demos and then we do testing, and that's always like, for example, fight detection model that we have. It's always so hard to showcase demo because, well, we're peaceful guys sitting here, and then you need to mimic the fighting, and that's not exactly not always works, and not exactly the
That's
case.
fun. Yeah.
Yeah.
Okay, got it. So I expect that threat detection industry is going to be really huge. I wanted to ask you about its current state. I mean, how many clients, or how many instances of installations do you see now, and what do you expect in the future? So my impression, I may be wrong here, is that right now it's getting more and more common to install automatic threat detection systems like everywhere, not only in major big facilities, but also in pretty kind of small shops, for example. So what do you think about the future of threat detection using artificial intelligence?
Well, you're completely right. Of course, because the field is new, the solutions are new. Of course, some people are still reluctant, and in some cases, these are people who are decision makers. So they are this like old police officer who is used to this old-fashioned way. So they are usually, even if they are presented this solution, we can judge by the questions they ask that they are not fully aware of the capabilities, and sometimes they over evaluate, they think it's magic. And sometimes on contrary, they cannot be persuaded that the system can augment what human person can do, and in fact in many cases it is doing the job much better. When I am asked about the limits of the system, when I'm given this, let's say sometimes I'm given this video footage and said, okay, can it detect the gun in this footage? The straightforward answer to that, like rule of thumb answer, is that usually what I'm giving is like, if you can see that, if you can see the weapon, then the system will do that, and most likely it will do better. The reason for that is not, I'm not thinking like a machine is superior, etc. The fact, the algorithm that is embedded in our at least in our solutions, is that it is zooming in this area. That's the checking and over checking. It has internal cascaded decision makers in the zoom in area that check and overcheck, and that's why we don't miss the weapon, and that's why we don't do more than 0.1 mistakes, 0.05 mistakes per camera per day. And if a human being could do 5 times in a second, zooming in the different areas, etc., well, that would be pretty amazing, and he will outperform the system that we are suggesting. But usually that's not the case, and especially with human factor errors and tiring and everything, 24/7 overviewing is a tough work to do. And losing off guards is a common thing. So long story short, augmentation of human capabilities in many aspects. We're talking about weapon detection, but if you look into in the solutions that we provide, it will be person countings when they pass. I mean, there are so many similar solutions which come with their own problems, and I will not stop on each and every one, but I can give some examples on common solutions that are there. And the way we overcome that, we are using the capabilities of computer vision, and typically they are they are faster, and they are 24/7, human factor, error free, etc., etc. Of course, with their own limits. It's not a magic. We cannot detect intentional violations, a question which we sometimes asked during the demos, because there's this magic bulb, the person who views and says, can you detect the intention? Unfortunately, and judging from some movies out there, luckily we cannot do that yet. But then, yes, if you can see that, then if a human being can see that, then most likely, if the system can do that, and maybe even better because of this integrated smart features that it can do, right? So yeah, that is major differentiator between. Well, that is the main thing that I am answering when a person is asking this question.
So it's like having a person expert, right? Expert in the field who is never tired, hungry, or unhappy, right? Looking at this area and deciding whether it's weapon or not, right?
Yeah, exactly. And again, using all the capabilities of the system. So just an example again, maybe very specific, but imagine 4K camera looking at something which is 40 meters away or 50 meters away. To see whether or not there's a weapon in the hand of the man out there, you need to zoom in this very small portion.
Yeah.
Now imagine the system that does it again 5 times a second.
Mm-hmm.
Zooms in the section and checks up, and then it doesn't miss a frame. It looks at each and every frame separately and does the analysis in time and does the specific conclusion based on that. Human being physically cannot do that manually, right? In certain area, yes, but not that fast, not that always jumping from here and there in a crowd of people, right?
Yeah.
So that's why in these specific cases, definitely the system outperforms human being. But still, it's an augmentation of existing surveillance system that you have there. So the final decision of making the action is still at human disposal. So they have to do the final decision. The system will not. Basically, what maximum it can do automatically, it will close the doors and wait for a confirmation of a supervisor to open them up.
Got it. So it's not autonomous at this point, at least yet, right?
In many cases, not.
Got it.
Not that.
So
we alert people. That's the idea.
Yeah. So you expect these systems to be more and more common in the upcoming years, probably exponentially. Right?
Yeah, for sure, and especially because of the technical background developing so rapidly. So initially, the whole AI became available and abundant due to this emerging, also the hardware beyond that, like GPUs that are utilized in most of the cases, made this public, made the background, the educational part that raised so many specialists, and also the testing, and physically you're available. I can run our system on my notebook and made it analyze 25 cameras. One notebook can analyze 25 cameras. So that's at the moment is more than we could dream of 10 years back. But what I see in upcoming future, so currently, for example, embedded solutions cannot be that accurate. Mm-hmm. Cameras that are being sold nowadays, they have some embedded analytics. But at the end of the day, what we experience, at least, many users, they kind of are, maybe they were overpromised some things, maybe they imagined things differently, but at the end of the day, they end up not liking that much the accuracy levels, because they have these misses and the false positives, especially, for example, motion detection in perimeter protection. it gives like probably like 30 alerts a day a camera. We know this number is from, let's say, real installations. And at the end of the day, well, guards are starting not to pay attention because the shadow raises the alerts and everything. Unless you put some smart analytics in this type of solutions. For example, we are providing one of our solutions, intrusion detection, based on actually content of the visual content. So if it's human being or a car or both, then you get the alert. Or we filter the false positives that are sent out from the camera. Mm-hmm. So for the moment, yes, embedded systems cannot afford being that accurate. But I foresee that in future, probably near future, there will be more and more smaller hardware that can provide this type of background, like the hardware with the base, so the solutions can be embedded locally. That's one of the directions, and also cloud-based solutions. Yes, all of our solutions can be both locally installed and cloud installed because we know the difference. Different end users want differently their architecture. We know the benefits of the cloud, of course, that's straightforward, no hardware needed to be bought, etc. But in my opinion, for the moment, cloud-based installations, they have two issues that are yet to be solved. Maybe with 5G, one of them will be more straightforward. That's a network. So the bandwidth is not always sufficient for the analysis to be fast and reliable and feasible. And the second is price. So for the moment, well, there are some affordable solutions, but at the end of the day, if you calculate, especially for low hardware solutions like ours, it's, as I said, it's really low hardware. You end up with numbers like you can spend 2 months of cloud payment and get the hardware permanently, buy the hardware permanently.
Yeah.
And also cloud-wise, people so far are not that much trusting that, especially speaking about the security. Sending the video feed to some cloud to analyze, not everyone likes that. Well, there are names out there which are trustworthy, but then still, it's something which is not that easy nowadays. So we end up having a lot of customers that want their own solution in their premises, no touch, no connection to internet or whatever is there, just closed up system. And yeah, we do provide that.
This makes total sense to me, and I would expect that in some facilities it would not be even possible to send the whole video feed due to remote internet connection not being so stable or something, right? And you cannot afford not detecting something because of unstable internet connection, obviously.
Yeah.
So this brings me to my last question about the general future of deep learning and computer vision, for example, for the next 5 years. So you already mentioned that embedded systems will be big, right? And also cloud systems will probably be growing, but maybe not at the same speed as embedded. So what other trends do you see based on your experience for the next 5 years?
Well, some ideas, definitely like generalization of solution. I also foresee, and likely and hopefully that will happen sometime soon, the monopoly. Currently, with AI solution, especially with hardware, there's some kind of a monopoly, and we all know that. The NVIDIA provides superb products, very good in everything, like hardware-wise, and also libraries that come with it, very nice and everything, but it's still a monopoly.
Yeah.
There's no alternative out there, and we all know what monopoly brings with it, right?
Yeah.
So that's one of the things I would at least like to see changed in near future, and but also like generalization of the processes. Like there are already some startups, some ideas. For example, there are some models that are out there existing, and you can purchase them and use them as is. Of course, not always the solution is the model. So there's a lot of things that, at least for us, we do post-processing, pre-processing. So, for example, usually our solutions are not just one single model, but a cascade of models. So, but anyway, I can envision there will be some markets of pre-trained and ready production grade models. That's one thing that will be there. I can foresee. And also, well, of course, hardware will go better and better, especially with new this breaking. I think that one of the recent news were like 2 nanometer scale. From IBM. Let's hope that sometime soon we will see that also in other fields like GPUs and everything. So that will add up, and maybe quantum computing will come to the field, also available to the general consumers and developers. Let's see that. And that will, of course, bring new opportunities, because there are many ideas currently that are on the collecting dust on the shelf, not because they are not cool and they're not feasible. I mean, they are at least they are feasible, but they are not commercially attractive. I can make something working very cool on one computer, but that will be for very specific task and very specific niche. For example, like let's say military solutions, which we stay clear of and everything. So I mean, in that respect, in some cases, yes, hardware is now more than even let's say it's pretty affordable. Just an example, for the hardware of the server, let's say of one of our solutions, I will just bring an example of one of the solutions. The hardware of the server, and server, we're talking about not just general computer, but like a decent server with everything included, 24/7 operation ready. So the hardware will be something like $50 per camera, the installation, and typically the camera itself costs more than that. We're talking about like surveillance cameras will be like 150, 200, 250. So it's like kind of a small addition on the camera if you want to install this server, and that will be analyzing 24/7 ever since, right? So it's not that, it's not the bottleneck currently. But then, of course, some other solutions are waiting their turn, just because commercially they wouldn't be that attractive if they are rolled out currently. Pulse estimation, to name one at least, like, or any solution that is based on pulse estimation will highly depend on number of people in the view, and they will not be available for, let's say, where there's a crowd, or they will require huge computing power to do the solution.
Got it.
To roll out the solution. That's an example.
Yeah, so you mentioned these marketplaces with already pre-trained models that work. It seems that we are very much aligned here. OpenCV.AI releases OpenCV.AI model place, exactly what you were talking about, very soon. So please check it out when it's a public release for this product.
Wonderful.
Ara, thank you so much. It was a wonderful talking. It was a wonderful talk. Very much insights. A lot of insights here. Thank you for sharing this with our followers.
Thanks a lot. Thanks, Anna. And yeah, let's boost this field. And as I said in the beginning, let's make the world also a safer place, if that is possible, with means of technical advantages and developments. And then that's what we are going to do.
Thank you.
Thanks a lot.
This episode is sponsored by Intel. Near human level of perception in an embedded device is not a science fiction, it's a reality. OpenCV.AI Kit, or OG, uses Intel Myriad X chip for neural inference and depth perception, and this combination results in almost human level of understanding. OpenCV.AI Kit is supported by a strong toolchain, including Intel's OpenVINO toolkit. OpenVINO toolkit can help you develop applications and solutions that use deep learning, and also to deploy these solutions across a variety of hardware, starting from CPU and all the way to visual processing units. Use OpenVino Toolkit to augment your OpenCV projects that need a deep learning module. It's free. Download it and try it now.